Yesterday, I got an email from a viewer, Jeff Shelley, asking the following questions. Quote, I really begin to question whether the current approach will ever be able to achieve robo-taxi level full self-driving. To a layman like me, it appears the current approach is a brute force, give it enough scenarios approach, versus some sort of an AI implied logic approach, an approach that instead suggests the AI can think and reason, if that is at all possible for current AI technology. End quote. This seems quite a reasonable approach. Let's discuss why it doesn't work. Hey y'all, it's Dr. Know-It-All. I want to point out first and foremost here that I am not saying anything against Jeff. These are extremely reasonable questions, and in fact for years a hard-coding approach to each situation was one that was favored by autonomous driving researchers. Even back in the 90s, cars could drive themselves, mostly.
And no driver for that matter. Scientists assure us that it's the
They could drive around test tracks and avoid test obstacles and such, but no one was going to let them out on the roads to drive themselves. Even Tesla started with this mostly hard-coding approach. As Andrej Karpathy, Tesla's director of AI, has stated in some of his talks, you can see above for some of the videos on this, Tesla's current, e.g. non-beta version of their full self-driving software is mostly hard-coded in C++. And Elon Musk famously said they barked up the wrong tree for years on full self-driving, and that was this hard-coded method of driving. So what's wrong with this system? Well, let's break down the driving process into three main components: seeing the world, understanding the world, and changing the world. Let's start with number 3, the last one, changing the world, or controlling your car. I just thought changing your world was a cooler way to say it. Anyway, this is a complex control problem, but it was pretty well solved in the 90s, so it's not really the sticking point for full self-driving. In fact, when you drive your Tesla yourself and the regenerative braking controls kick in, that's similar to the full self-driving systems. Anyway, this software is really complex and very interesting, but it's a well understood problem by now, as they say. So most people think of the sticking point as point number 1, seeing the world. Most press is about LiDAR versus vision and the competition between them and which one is going to be better. And of course, this is still an outstanding question. Vision is closing the gap on creating pseudo-LiDAR images. Again, you can see here for some videos on that. But LiDAR is also getting far cheaper and more robust to build. So I'm personally not absolutely sure which solution will win out, and maybe both will in the end. I have a feeling Tesla's pretty close to solving this with just vision, but even for Tesla, I think if it gets cheap enough and robust enough, they may actually stick a front-facing LiDAR in there as a supplement to vision. Just depends on the situation, but we'll see. Anyway, this raw vision thing is a very complex issue also, but it's still not the sticking point right now. So what is the sticking point? As you might guess, it's step number 2. Feels a little bit like the underwear gnomes.
Don't get it. You see, phase 1, collect underpants. Phase 2, phase 3, profit.
So what is this semantic or sense-making step? That's where the raw vision or LiDAR or sonar or radar data has to be processed so that a bunch of colored pixels become knowledge about the world around the car. Some relevant questions are things like, how far away is this pixel? How does this pixel from camera 1 compare to this pixel in camera 2? In other words, how do we stitch together different camera views? How do these pixels relate to radar or LiDAR pixels? What does this particular collection of pixels combine to create? What is the object that arises from this group of pixels? How far away is this object? How fast is this object moving? Should I care about this object? As in, is it a tree on the sidewalk or a dog running out in front of me? And finally, how does all of this information relate to what I know happened last evaluation period or the previous frame? So in short, every single object in the scene needs to be identified. Unimportant objects must be rejected or eliminated. Important objects must be classified. In other words, static objects like curbs, roads, lines, parked cars, garbage cans, etc. Changeable objects like streetlights need to be recognized, and dynamic objects like other moving cars, people, animals, etc. must be identified. Also, occluded objects must be identified. In other words, something like a stop sign with a tree in front of it, or a light that's partially behind a hill or something. And all of these objects must be matched with other objects in the previous frames for continuity of data. Again, you can see my trajectory projection video up here if you want to. Then, and only then, can these results be passed on to a decision-making level where the necessary acceleration, braking, and/or steering decisions are made. And then, of course, this decision is passed on to step 3, where the car actually controls itself. Alright, so just code in all these situations and we're golden, right? Well, no, that's the problem. First of all those etceteras that I was mentioning before are extremely important. It's not stop signs, lights, and yield signs. It's stop signs, occluded stop signs with except for right turn, vertical lights, horizontal lights, flashing yellow lights, school speed limit lights, and on and on and on. And each individual light or stop sign looks different under different conditions, like night versus day, or rain versus cloudy versus sunny, and different from every other stop sign or light in the world, and on and on. In other words, the real world is extremely complicated and messy. People started out doing autonomous driving by coding in examples one after another, and this works great in simulations and even in carefully controlled real situations. But as you try to expand this to more and more real situations, in other words, you're starting to chase the nines, as they say, the number of cases you have to code for explodes exponentially. It goes like that. In other words, trying to write a bunch of rules to extract explicit meaning. In other words, this is a car. It's 45 meters away from me, moving toward me at a relative 90 kilometers per hour, and it's relatively 3 meters to my left, so it will pass me in 0.5 seconds, but I could ignore it because it's in the other lane, is an intractable problem. Almost every new situation, including the same situation under different lighting or weather conditions, is a new rule to be written and tested and implemented. In just a second, let's discuss what we need, but first, if you enjoy this video, definitely like it so other people can find it, and of course subscribe for more of this. Also, a big shout out to my patrons on Patreon. Thank you all so much. We have a new patron since last time, Rick Thor. Awesome last name, by the way, Rick. Also, a big shout out to Zenly Music for doing the intro and conclusion music. You can search for him on Instagram or YouTube. Also, check out our Tesla referral links and our Amazon affiliate links in the description below. If you click on those, you help out the channel, so thank you very much. So what do we need? What we actually need is much more human. We need to get close enough from a general set of rules and observations that are flexible. And this is where neural networks come in, and again, you can see my videos on this above. Artificial neural networks can approximately model almost any function, call it any situation if given enough data. And yes, for those who will get on my case about this, technically a big enough neural network with enough data can exactly model any function, but in practice it's approximate. And in a situation like driving, approximate is fine. Think of you as a driver. You're in a new town, you see a new light and new cars with different license plates, and there are different trees, and maybe the traffic lights are horizontal rather than vertical, which is what you're used to. But all of these things are close enough to what you know so that you can still effectively drive there. So a neural network can be trained on enough data and with clever enough models, and by the way, this is no simple task, just to be clear, that it can recognize 99.99 something % of situations. And it can likewise be trained to give the correct, or at least approximately best, solution in 99.99 something % of cases. Again, this is just like us humans. In some 0.001% or so of cases, we get into accidents in cars because we simply don't understand the situation at hand. Now, most of the accidents we do get into are due to distraction or other reasons, but once in a while the situation is just too different and we don't react properly. And the benefit here, of course, for neural networks is that they have billions of miles of experience rather than our hundreds of thousands of miles at best experience, and they can share with each other. So in the end, I'm convinced that neural networks will be able to drive better than us. And in fact, the evidence is quite clear that under normal circumstances, this is already the case. But that is not because we've cleverly coded every single possible situation into our full self-driving cars. It's because we've been able to model what humans do naturally, extract general and flexible rules that can be applied to new situations when needed. This is why we need machine learning and massive data and excellent complex neural network models. We just need to do a good enough approximation of the real world rather than an exact solution to every possible problem so that our cars really can drive themselves. All right, I hope you enjoyed this episode and found it informative. Thank you so much to Geoff for suggesting this and asking the questions. These are really, really excellent questions. I hope I helped to answer them to some extent at least. If you enjoyed it, definitely make sure you like and subscribe, and definitely ask me questions in the comments or at my email address, which is DrKnowItAllKnows@gmail.com. Till next time, bye-bye.